Hello. So in this video, we're going to be connecting special right triangles to the unit circle. So special right triangles we've covered in geometry, so I'll just do a quick little recap. The first special right triangle is the 45, 45, 90 triangle. And this guy is created from an isosceles triangle, so you'll see I kind of have him all set up here. So I can use the Pythagorean theorem to find the length of C. So using Pythagorean theorem, a squared plus b squared equals c squared. And going through and solving for this guy, I get that the length of the hypotenuse is the square root of 2x squared. I can square root x squared, so this would be the length of my hypotenuse. Why this is useful is because now I know that if I have a 45, 45, 90 degree triangle, the ratio of my sides would be x 2x, 2x rad 2. Okay, so that's kind of cool because if you know that the leg is 3 of this right triangle, then I know the other leg would be 3 and the hypotenuse would be 3 rad 2. I can also go the other way. So for example, what if I told you C, the hypotenuse length, was 1? Okay, so then if I wanted to go backwards, I'm starting with 1. I have to divide by rad 2 to get the other legs. So if this were 1, x would be 1 over rad 2 in both cases, right? And if I had to rationalize that, multiply both sides by rad 2 over rad 2, these sides would be rad 2 over 2. This connects to my unit circle. So remember that when we're thinking about a unit circle, the radius of this triangle, right, or the radius of this unit circle is 1. It happens to do with this right triangle. So if I say, hey, I have a 45-degree angle here with a radius of 1, I know the side lengths would be rad 2 over 2 and rad 2 over 2, using that information I just gave us up above. So this is good for a couple of reasons. We now know that the sine of 45 is rad 2 over 2, right? Because it would be opposite over 1. The cosine of 45 would be the adjacent over my hypotenuse, which is 1. And last but not least, my tangent of 45 is sine over cosine. Something divided by itself is 1. These are all things that you have to have memorized. Now, this is written in degrees. Typically, when we're thinking about circles, we like to think in radian mode. So in radian, yeah, we have to like to think in terms of radian. So I need to convert 45 degrees to radians. So I will divide it by 180 degrees. I'm multiplying by a smart version of 1. Pi over 180 allows me to convert from degrees to radians. Oops, this should say pi radians. So uh, 45 divided by 180, I'm left with pi over 4. So the other equivalent version of this is sine of pi over 4 is rad 2 over 2. Cosine of pi over 4 is the same. And last but not least, tangent of pi over 4 is 1. So these are things you'd want to commit to your memory bank.